All right, so let's take a look at the connective tissues, big group of tissues called connective tissues. Okay, first one in your packet is adipose tissue, so adipose tissue. Okay, and adipose is our fat guys. So the cells, they got these adipocytes. Remember, fat cells. Okay, over here, and all they do is they store fat. Most common spots you'll see it are right underneath your skin. We have a layer of fat. It's called the hypodermis. We're going to see that next unit. We also see it padding around different spots around the eyes and the kidneys, and so the eyes and kidneys are listed up here. Okay, functions. Well, it does store energy, right? Fat stores energy, but it's an insulator, and then you got your padding and your cushioning. All right, nothing terribly special there. Let's go to the next one. Okay, next one's reticular. Okay, so reticular. Okay, if we look at reticular, if you look at locations, we got liver, kidney, spleen, lymph nodes, all these locations over here. Okay, it's kind of like a sponge. Okay, it's not terribly strong. It's a really light framework. Remember, reticular fibers are not terribly strong fibers. So it's more just like a kind of spongy network that holds things together. So that's the basic use there. All right. Next one, okay, loose fibers. Okay, loose fibers. Sometimes it's also called areola there. Well, first of all, look at the structure. It's got some reticular fibers, so it's got some web in there. It's got some elastic fibers. It's got some collagenous fibers or collagen fibers. Okay, so it's got a little bit of everything. It's just your general connective tissue. You typically find it. The most common spots are underneath the skin. You find it holding the skin to the muscles, but it's also a lot of times just used to fill spaces in the body, guys. So it's not terribly specific, but you're going to see because it's got the reticular fibers can cover a wide area. Elastic fibers give us some flexibility. Collagenous fibers give us strength. It's got a little bit of everything. It's fairly strong. It's a little bit elastic. It's a little bit of a network. So it's kind of general, all-purpose filler. All right. All right. Blood, really easy. Okay. Please don't be confused. These are just parts of the blood. So red blood cells, platelets, and white blood cells. Those are just the cells that are found in there, but blood is the tissue, okay? And red blood cells, okay, transport gases around the body, oxygen, carbon dioxide. Platelets are involved in blood clotting, and white blood cells are fighting infection, okay? So they transport stuff around the body, and the particular cells, that's what they do. All right? Next one on here, bone. Real simple, guys. You find bone in bone. How about that? All of this detail in here, we will deal with all this kind of stuff. You can kind of ignore for now, guys, except for just kind of recognize the terms, okay? So if you happen to see any of these terms, osteocytes, things like that, you want to recognize it as being part of bone, okay? But the functions are just like what you expect, guys. Support, okay, protection, like the skull protects the brain, and the vertebrae protect your spinal cord. You have the production of blood cells because the bone marrow, which is down here, is inside of the bone. So a lot of times it's thrown in there. And then this one's huge for us, but we haven't really done much with it. Another 2 weeks from now, and we will. We'll talk about how it helps maintain blood calcium and why that's so important. But it's really important for us, so it's a good one to know. All right. Bone marrow, real simple, makes our blood cells. Okay, it's found inside of the bone, and it makes our blood cells. Red, white, platelets, all three of them. All right, moving on. All right, so here's where people tend to get confused. All right, so dense regular. If you look at dense regular, the key is see how everything's going in the same direction. They're all strings kind of going in the same direction. All right, now they get a little wave to them, but they're all going in the same direction. Okay, keys. Collagen, really strong. Remember, collagen is our strongest stuff, so it's going to be really strong. But they're really only strong if you kind of yank on it like in this direction or this direction, okay? If you started pulling this way, it would be like pulling it apart like like cloth. It would actually shred fairly easily, okay? So it's really good for tying things together in a very linear direction. So it's like, imagine you've got a muscle on this end, and you've got a bone on this end. It can tie those two things together, all right? Down here we have dense irregular. So the irregular refers to the fact that some of it's going this way, some of it's going this way, some of it's going this way. It's all over the place. All right? And what that allows us to do is have strength in multiple directions. So if I yank at it from this way and pull that way, it's going to hold together. If I pull that way, it's going to hold together. If I pull that way, it's going to hold together. So it's just strong in any direction. So we use it around organs, just around organs. But the key is kind of, it's not specific, like up above with dense regular, it's specific kind of in one direction. You start pulling these two things. This one, it's like a nice cloth. You can pull at it from any direction and it's not going to give. Right? And then finally our last one on this sleeve is elastic, and what makes it special, it is elastic, it's stretchable, okay? So it's got a whole lot of elastic fibers in there. So these guys were mostly collagen up here, okay, very strong. Elastic isn't nearly as strong, but it allows us to be able to move things. So the most common spot is back here on the back of your spine, okay, between the vertebrae, okay. And when you lean forward, like you're touching your toes, this would stretch, okay. But it's going to prevent it from going too far, because remember, inside here you also have the spinal cord being protected, so you wouldn't want the spinal cord getting stretched too far. So it's like some stretching, the rest holds it in place. All right. You'll also see it sometimes in different organs and walls of blood vessels is a big one that we'll see. But that's what's special about it. It's elastic. Cool. All right. And our last three of the connective tissues are the cartilages. Okay, so hyaline cartilage, elastic cartilage, fibrous cartilage. Okay, so hyaline cartilage up here, hyaline cartilage is the most like plastic. Okay, it's not terribly flexible. It's pretty stiff. It's real shiny, and you see all this real shininess up here. You'll find it in at the ends of bones. That's what covers the ends of your bones. Oh, sorry. It's going to cover the ends of your bones. Sorry, I can't. I'll ignore that. And that's what helps reduce the friction. That's what people lose when they have arthritis. They wear that away. You also see some of it in the trachea and things along those lines. Right? A little bit of flexibility, but pretty solid. Pretty solid. Something a little more flexible than bone, but not too much more. All right. Elastic cartilage, as the name might imply, has a whole lot more elastic fibers and is much more flexible, guys. So it tolerates, I put down here, tolerates distortion without damage and returns to original shape. Okay, so you can stretch it, you can move it around. Like if you think about your ear, you can kind of fold your ear in half, and it's going to bounce right back into place. All right. And then the last one down here is completely different function, guys. Fibrous cartilage is a shock absorber. It's a padding, okay? You find it in the vertebrae, so every time you jump, if you look right here at these little blue pads right there, that's what I'm trying to show you. Every time you jump, your vertebrae separate a little bit, and then they slam back together when you hit the ground, and that's a pad between there, okay? You also have this in your knees, so between your femur, your thigh bone, and your tibia, which is your shin bone, you have the same stuff. And it prevents the two from smashing together. In fact, if any of you heard of a meniscus, this is what a meniscus is. A meniscus is made out of this fibrous cartilage, and it's just a padding right between the two bones that prevents them from smashing into each other. All right? So, a couple last things about connective tissues. Remember, number one, connective tissues typically have lots of empty space. So this picture is an excellent example of it. You got one cell, another cell, and it's not empty space, sorry, extracellular space. So you have all this the space stuff out here, that's what we call the matrix. Remember, the matrix is filled with either the fibers, like we have up here, and the ground substance, which is the fluid. There typically is a lot of fluid that's mixed in there as well. All right. I'll get to the muscular and nervous in a separate little video. All right. Hope if you have any questions, come see me.